All right, we're going to figure out how to find area of triangles today on a grid. And to do that, we're really going to take these triangles and turn them into rectangles because those are really easy to find on a grid, kind of like how we did parallelograms when we sheared them to make them into rectangles. So essentially, you should know that the area of a triangle is 1/2 base times height. And the area, so this is a triangle, the area of a rectangle is just base times height. So the reason it's half of that is if I take this triangle and I copy and paste it. So in fact, I'm even going to trace over it here for you. Okay, so not perfect, but you get the idea. And I rotate this and stick it on top, I have a rectangle. Okay, so two triangles make one rectangle, which makes sense that the triangle formula is half of a rectangle formula. All right, so that's how we would draw a rectangle for this one. I'm going to do the same thing here where I'm going to trace over and rotate, but you could just draw straight up and over, straight up and straight over. So there's one piece. Here's another. And there's my rectangle. Okay. Here, I'm actually going to make this a straight up side. Kind of like how that one is, like this is my height instead of on the outside. And now I'm going to, first let me walk that. Now I'm going to do the same thing that I was doing before. Move this piece. Just down there like so. And then the same thing here. I can do better than that. Okay, like that. And then you see we have a rectangle on the outside here. Okay. So using dissection, demonstrate why the area formula for a triangle is 1/2 base times height. Label the dimensions of the resulting rectangle in relationship to the original triangle. So same thing here. If I make this into a rectangle, then I have 2, 1, 2, 3, 4, 5. So the area of the rectangle is 10 square units, and the area of the triangle, half of that, is 5 square units. Okay, because there's 2 triangles inside this one rectangle. So I take that and divide by 2. Or here, if I'm going to turn this into a triangle, I can flip this piece up and this piece up to make a rectangle. And then I have 1, 2, 3, 4, 5 by 2 again. So same thing, my rectangle is 5 units and my triangle, my rectangle is 10 units, my triangle is 5 units squared because this whole thing is 10. And then you know that this is half of that because we copied the same pieces twice. Use the box technique to find the area of the following triangles. So I need to turn these into a box. So it helps if you have a height in here. Actually, I'm going to skip this first one for now because it's going to be a little bit different and focus on the second one first. So I'm going to take this piece and flip it so it's up here. I'm going to take this piece and flip it so it's up here. Then I have 1, 2, 3, 4 by 1, 2, 3, 4, 5. So I could do The area of a rectangle is 20 square units. So the area, again, this is my rectangle. My triangle, you could take half of that, is 10 square units. Okay, for this one, I'm going to make a square on the outside. The reason we do this is because it's not easy to find our base and our height without using the distance formula. So I'd have to use the distance formula to find my base and my height on this triangle. This one, it's not really necessary because I have a horizontal base and a vertical height, and they are pretty easy to count. Which is why I wanted to do this one first, because it's easier. But I can't tell my height or this base very easily without using the distance formula. So that's why we're doing this. But when you make a rectangle, it's easy to find your height and your base because they're horizontal and vertical. So on a problem like this, you wouldn't really need the box method. Or on this one, it's easy to find your height and your base. Easy to find your height and your base. But this is the type of problem where it's actually going to be more helpful. So here my height is 2 and my base is 3. So the whole rectangle is 2 times 3 for your area, which is 6 units squared. Now, I can't just divide this by 2 because these pieces on the outside are more than the pieces inside this triangle. I didn't just take a piece and flip it up on this one like I did on the others. So what I have to actually do is find the areas of these triangles because they have nice bases and heights because they're horizontal and vertical instead of diagonal. So I have to find the area of each one of these. So if I do the area of triangle 1, that's 1/2 2 times 2, which is 2 square units. For triangle 2, I have 1/2 times 1 times 1 is 1/2. And for triangle 3, I have 1/2 times 1 times 3 is 1.5. So then if you add those up, total, you'd have 4 units. So you would take your 6 units squared minus 4 units squared equals 2 units squared. Okay, this is now the area of this triangle in yellow here. Okay, that's how we found that. You could also use the distance formula to find your two sides and then take 1/2 base times height. But even though this looks like a lot of work, it is faster than the distance formula, I would say. All right, so that's how we do that type. Your assignment for today are pages 18 and 19.